Hi, how's it going? This video is long overdue, okay, long overdue. So it's about the chain rule, product rule and quotient rule. Just be aware this video is not about proving them. I'm not going to prove these results. You can look that up somewhere else if you want. Now this video is all about helping year 13 students, math students, to use these rules for particular questions. I mean to understand how to actually use them, okay? So here's the 3 rules. I'll just move out in case you want to take a screenshot of those, and I'll show you via a series of examples how to use them. Ready? Okay, let's go. So first one. So use the chain rule to differentiate this. Now why do we use the chain rule? It's really to make it an easier question. That's what the rules are for, to try and break down a particular expression to make it easier to differentiate. And when we first glance at this, when you've not seen the chain rule before, you notice that it's the brackets that's making it rather difficult. If it was something cubed, like x cubed, it'd be easy to differentiate. But because it's something a bit more complex than that, okay, we're going to use a rule to actually differentiate to make it easier. And what we're going to do is we're going to let the interior of the brackets equal to u. So whatever is inside the brackets, it's 2x plus 3, we're going to let that equal to u. All right? And what that allows us to do, it allows us to rewrite the expression as u cubed. So you've got y equals u cubed. Okay? And we can differentiate that. We can differentiate y with respect to u. Okay? So make sure that you're using the dy du appropriately here. When it's y in terms of u, it's dy du. And differentiate that using P1 subject knowledge, it's 3u squared. When I say P1, I mean year 12. I realise some people might watch this and they're not from the UK. Okay? This here we can differentiate as well. So if you've got u in terms of x, you can differentiate that with respect to x. It's du dx, u in terms of x. Okay? And that is just 2. Now the chain rule is this. Why does this work? Let's just take a moment to consider that. If we just treat this like a fraction, dy divided by dx, literally dy over dx, you can rewrite it as dy du times du dx. Because treating like fractions, the du's will cancel. And you've got dy over dx. That's not a proof, okay? It's just a demonstration as to why it actually works. And being able to spread it up into the product of 2 different derivatives is easier for us to handle, okay? So having got dy du and du dx, we're going to put them together. Dy du times du dx. So therefore, our answer is going to be this multiplied by this, which we get 6u squared. Now, because we're differentiating this with respect to x, okay, we've got to write our answer in terms of x, so it'll be 6, and then u is that 2x plus 3 squared. Okay, that is it. Just 6, 2x plus 3 squared. Happy with that? I'm hoping so. Now, you're going to have to be able to do this in your head. Let me just explain to you how you're supposed to do that. Okay, just consider this we have in brackets. Okay, we'll write a different colour here. Well, it doesn't matter what we have in brackets, okay? Suppose it's something else, I'm not going to say what it is, okay? Let's just call it f of x, some expression in terms of x. If it's that cubed, what we do under normal circumstances of differentiation is bring the power down, so that will be 3, and decrease the power by 1, isn't it? So it will be 3 times that squared. And then notice what we're doing here is we're differentiating what's inside the brackets, okay? So here the bracket was 2x plus 3. We differentiated that. And if you notice our answer, it kind of fits that pattern. It definitely fits that pattern, doesn't it? Okay, because you've got the thing in brackets is u cubed, and then 3u squared, and then multiplied by du dx. So you've got 3 multiplied by f of x squared, multiplied by f dash of x. Okay, and that's a standard result you could use. Now, we don't have to use power 3. We can use any power. So let's just call it power of n. So if we want to find what dy dx is when it's f of x to the power of n, then dy dx would be n multiplied by f of x to the power of n minus 1, decreasing the power by 1, times by f prime of x, f dash of x. Okay, let's have a look at some more examples. So here we go. Differentiate this with respect to x. Maybe you've seen that before. The WRT means with respect to. Okay, and it's just a nice little abbreviation when we're differentiating things. Okay, because we're not always differentiating with respect to x. Sometimes it's something else. Now we could write it out using the chain rule. So u equals du dx equals y equals dy du equals, or we could have a go in our heads. Okay, maybe you pause the video and have a think about it for a moment. Whatever method you want to do, it's fine. Did you do that? Maybe you did, maybe you didn't. Okay, but I'm going to go ahead. Okay, so you can pause these videos, which makes it quite convenient when it's posted online. You see, in a classroom you can't just pause. Maybe we should give that a go. Maybe we should just sort of freeze, hold a pose, and just while they work it out. Okay, and then unpause. Right, let's go. Yeah, maybe. Right, so what I'm going to do is I'm going to bring the power down and I'm going to write out the bracketed expression again. There's a 2 missing there somehow. And decrease the power by 1. Okay, so 5 times by this, and then decrease the power to the power of 4. Then differentiate what's in the brackets. So differentiate that, we get 6x minus 2. That's it. Done. Maybe you could write it a little bit better. So the convention is we put the number first, and then this will be second, simply because it's a lower power, and then this will be next, 3x squared minus 2x to the power of 4. That is it. Okay. There's no need to expand brackets. Okay. No need to expand brackets. The thing about it, one of the reasons we differentiate is to find the gradient at a particular point. Well, it's easy to substitute the value of x in when you don't expand the brackets. Most often I find anyway. I'm not the type you're trying to find a stationary point. You set dy dx equal to 0. Easier to set that equal to 0 and solve for x than if it's expand. If you think about it, when you expand this, what's that going to be? X squared to the power of 4, x to the power of 8, isn't it? Times by x to the power of 9. You don't want to solve an x to the power of 9 equation. You do not want to do that. Okay, so keep it all in brackets in factorised form. Okay. Let's move on. Let's do another one. Now, this one. Okay. For those of you who've seen the quotient rule, you're probably thinking, oh, I can use the quotient rule on that. Yes, you can, but you don't have to. Okay, I'm setting this up as a chain rule question. Okay, but you can use it as a chain rule, and it's actually easier if you rewrite the question out like this first: 3 and then 2x plus 1 to the power of negative 4. You know, in other year 12 type differentiation questions, when you're often writing index form, as opposed to when it's written as an algebraic fraction like that. So 1 over x, for example, you might write as x to the power of negative 1. So this you write as this to the power of negative 4. Then we can use the chain rule to differentiate it. Again, if you want, you can just pause the video, have a go at it, and then just unpause it and wait to see if you got it right. Okay, maybe you've done that. So negative 4, bring it in front. There's a 3 there already. So as with any year 12 differentiation, you just multiply them together. So negative 4 times by 3, which is negative 12. And then the expression in brackets, 2x plus 1, decrease the power by 1, power negative 5. That's that bit done. Then differentiate what's inside the brackets, it's 2. Okay, so multiplied by 2. We can simplify that. So that will be negative 24, and then 2x plus 1 to the power of negative 5. If you want, you can rewrite it, there's no need, but you can. It's just the same as this, negative 24 over 2x plus 1 to the power of 5. Okay, that's it, it's easy. Hope you find this easy, because they need to be easy for you, okay, because there's much harder differentiation coming up in year 13 course than this, okay. You have to use a chain rule pretty much every differentiation question you do, so you need to be able to get used to doing this as quickly as possible. Got one more for you. This one here. So here, you'd have to write as 2, 3x plus 4 to the power of negative a half. Again, you could use the quotient rule if you want, but I'm setting it up as a chain rule question. You could do this just using the chain rule, because you've just got a number on the top, you see. And so you just treat it as just one single expression where you can just differentiate it using the chain rule quickly. Okay, so happy with that? Over root is same as negative a half. Pause the video again, and then unpause it to check your answer. So negative half times by 2 is negative 1. So I'll put negative there. 3x plus 4. The 3 didn't come out properly there. To the power of negative 3 over 2. That's decreasing the power by 1. Then differentiate inside the brackets 3. Or I can just sneak the 3 in there actually. There. And that's it. Done. You don't have to rewrite it. Okay. If you did rewrite it, it would be negative 3 over, that's the negative power, and it's best to write it as this way, isn't it? 3x plus 4 to the power of 3 over 2. You don't need to, that one would be fine. Okay? That's it. That's the chain rule. That's how simple it is. Now, next we'll do some product rule questions. Okay? Here is the product rule. Like my picture of Newton? Yeah, okay. Obviously, because Newton is credited with the discovery of calculus, along with, hold on to that thought, maybe you know who it is. He'll come out later. This is the product rule. Okay. Now, as I said at the top of this video, I'm not proving these results for you. I'm not about to prove that for you. Okay. That's not what this video is about. This video is about how to use that for a question like this. Now, when do you use a question like this? It's when you've got the product, the multiplication of two separate expressions. So here you've got x squared multiplied by 2x minus 5 cubed. Okay, that's when you use the product rule. Okay, so when you've got an expression such as y is equal to one function of x times another function of x, so u times by v. So what we do is traditionally let the first term be u. You don't have to. You can do it in any order you wish. Sorry, Isaac, I'm going to have to just put you some rush. And v is the second term. Okay, it doesn't matter which order you do it. So you can choose either one of these to be u or v, but I just do it in the order in which they come. Okay, so u is that, and v is this. Okay, as with the chain rule, when we've got u equals something, we can differentiate that. So du dx, differentiate that, respect to x is 2x. Here we're going to differentiate this, so it's going to be dv dx this time, because it's v in terms of x. So differentiate that. Now notice you're going to have to use the chain rule to differentiate that. That's what I meant when I said earlier, that every time you do a differentiation question, often using the chain rule. Okay? So we need to use the chain rule to differentiate that. Okay? So 3 in front, and then 2x minus 5 to the power of 2 multiplied by 2, because it's the derivative, that's in the brackets. So 3 times 2 is 6. So we've got that. Okay? And for goodness sake, do not expand the brackets there. You'll get into an awful mess. Now, the product rule is quoted as this. You do v multiplied by du dx plus u multiplied by dv dx. Please do it in that order. You don't have to, but you'll see why it's going to be useful for you. So this times by this times by this. If you always set out your working like this, u equals du dx equals v equals dv dx equals, you're always going to be multiplying those together and then those together. Okay? If that's a helpful way for you to remember it. So this times by this. So 2x and then 2x minus 5 cubed, okay, plus u dv dx, so that times by that. I'm going to write it as 6x squared, 2x minus 5 squared. Okay, preferable to put the x squared in there rather than the end. Okay, that is it, that's it differentiated. However, you can simplify it, and that's where the question gets a little bit harder for some students. Okay, not the differentiation bit, but the simplification bit. So how do we simplify this? While you're thinking on that, I'm just going to rearrange my screen a little bit. Just going to get rid of this. Move this up. Maybe you've had a thought already about how to simplify it. We factorise. Factorising is the key. So we've got to put the common factors between this and choose the highest ones. So 2x, okay, because 2 is the highest common factor of 2 to 6. X is the highest common factor of x and x squared. And then we've got the brackets, 2x minus 5, highest common factor there is squared, the power of 2. So that is common to both terms. Okay, when I'm factorising like this, I tend to use a different type bracket, just to emphasise this is what's going on outside and this is something inside. So this multiplied by 2x minus 5 would give us the 2x minus 5 cubed. And then this term, the 6, we need to have 3 x to get 6x squared, and the 2x minus 5 squared is already there. Okay, so that easily done. Easily done. We'll just tidy it up a little bit. 2x minus 5 squared. I use normal brackets now. 2x plus 3x is 5x, and then minus 5. And while we're factorising, we can factorise this a bit further, because I've got 5 now in both of these. So I'm going to take 5 outside the brackets. So 5 combined with the 2 makes 10. 10x, and we're left with x minus 1 here, aren't we? So I'm going to write the x minus 1 there, and then the 2x minus 5 squared there, just because I like having the order of power 1, power 2, and so on. Okay? That is it. That's that question done. I've got one more for you. Here. And there's the other one. Okay, the other inventor of calculus. Okay, Leibniz. Okay, just for balance, 1 Newton, 1 Leibniz. Okay, so there is. This one here. Now, product rule again, because as I said, it's product of 2 separate terms. 3x cubed, separate to root 2x minus 7. All right, so set it up as u equals and v equals. So u equals 3x cubed and v equals, and we'll just say goodbye now to Mr. Leibniz. And v equals, let's write that as 2x minus 7 to the power of half, square root of 2x minus 7. Differentiate each of these one at a time. So du dx is equal to, that will be 9x squared. And then dv dx, can you see you have to use the chain rule to differentiate this. So half in front, half 2x minus 7, decrease power by 1, negative half. Differentiate, what's in the brackets, 2. 2 times a half, that is just 1, so it's just going to be that in there. Okay? And then we substitute into our product rule formula. So we've got dy dx is equal to v du dx, so that times by that, 9x squared 2x minus 7 to the power of a half, added to u dv dx, so that times by that, 3x cubed 2x minus 7 to the power of negative half. And that's the differentiation bit done. But we can simplify it. We can simplify this. It's a bit harder to simplify. So again, I'm going to rearrange my board, and as I'm doing that, maybe think about how to do it. Of course, if I'm going too quick for you, all you have to do is just rewind the video and play again. In lessons, I don't normally do it this quick. I normally wait for people to have this written down, ask any questions they need to, that sort of thing. Right, how are we going to do this? Not by factorising first of all. Okay, why is that? Because of the negative power here. I'm going to rewrite it like this first of all, and then hopefully you'll get the idea. So the first term I'm going to keep as it is, but the second term I'm going to rewrite like this: 3x cubed over 2x minus 7 to the power of a half, because that's what negative power means in it. In this one, the simplification is about combining 2 terms by considering lowest common denominator, like adding 2 fractions together. Okay? What I'm going to do is have a common denominator. Okay? So the common denominator, I'm hoping, is obvious. So write it out as one long vinculum. That's the dividing line of a fraction. The common denominators will be 2x minus 7 to the power of half. Okay? So that won't change, it'll be 3x cubed. Here, we just change that to over 1, rewrite it to over 1, multiply top and bottom by 2x minus 7 to the half, produce left with 9x squared, and then 2x minus 7. Okay. And then this, as I said, it's unchanged, it's 3x cubed. That's it, already a lot simpler, because it's now one single fraction as opposed to 2 separate expressions. Okay. Expand this, so it's 18x cubed plus 3x cubed. So it's 21x cubed minus 63 x squared all over 2x minus 7 to the power of a half. Now we can just check to see if it factorises again and simplifies any further. You can factorise the top to 21x squared and then x minus 3. And then over 2x minus 7 to the power of half, but, of course, nothing will cancel, so that's its simplest form. So you may as well have left it like this, okay? But just do bear in mind in an exam, you could get a show that question. The show that question could be, given that y equals this, show that dy dx equals that. In which case, you've got to go through all of this simplification process in order to get a result. Okay? Lastly, the quotient rule. Here it is. Okay? Here's the quotient rule, designed for when you have a fraction. I kind of briefly mentioned this earlier, okay? But a fraction when you've got 2 expressions in terms of x on the numerator and denominator separately. Okay? When you set this up, you always let the numerator be u. So the numerator is 2x and the denominator is v. Okay? So with the product rule, you've got u multiplied by v. With the quotient rule, you've got u divided by v. Okay? And then similar process to before, you do du dx, that's 2, dv dx, which is equal to 3. It's nice and simple, isn't it? No chain rule required for those. And then you substitute them into the quotient rule formula. Again, I'm not proving that for you, I'm just showing you an example of how to use it. So that's what you need to do for your A-level course. Notice how similar that is to the product rule. The product rule was v du dx plus u dv dx. That's why I prefer you to do it in that order. If you did it in order v du dx and then u dv dx, you'll find it easier to remember that order, because you must do it in that order for the quotient rule. So v du dx, that times by that. So 2, 3x minus 5. Subtract u dv dx, so that times by that, which is 6x. And then all over v squared, which is this, 3x minus 5 squared. Done. Only a little bit of simplification to do, which I can just do here actually. 6x, subtract 6x, 0, negative 10. Negative 10 over 3x minus 5 squared. Done. One more example. Here we go. Maybe pause the video, have a go at it, unpause, see how you get on. Right, u equals 3x squared, v equals 2x plus 1 power of a half, du dx equals 6x, dv dx, using the chain rule, is equal to a half times 2x plus 1 to the power of negative a half times by 2, so there's no coefficient there. Then substitute them in to the formula. dy dx equals v du dx, 6x, 2x plus 1 power of a half, subtract u dv dx, 3x squared, 2x plus 1 to the power of negative 1 half, all over v squared, which is just going to be 2x plus 1, because that squared is to the power of 1. Done. That's the differentiation bit. Would you know how to simplify it? Think about it for a moment if you want. Pause the video, take all the time you need. But I'm going to suggest in this case, because it's already set up as an algebraic fraction, we don't need to do the common denominator thing because it's already there. Just multiply the top and bottom by 2x plus 1 to the power of a half. 2x plus 1 to the power of a half. And the reason is because then you can simplify this quite a lot, as I'll show you. So this will become 2x plus 1. The second term is just subtract 3x squared, because we're multiplying by 2x plus 1 to the power of a half, all over 2x plus 1 to the power of 3 over 2. Okay? Simplify a little bit. 6x squared, so 12x squared minus 3x squared is 9x squared plus 6x all over 2x plus 1 power 3 over 2. That's it, we're done. No need to factorise any further because nothing will cancel on top of the head. Okay. I'm really hoping you found those very useful. Chain rule, product rule, quotient rule. I've done it purely in terms of algebra. You need to be able to do it in terms of exponentials, natural logarithms, trigonometry, all of that as well. But these examples, just using algebra, just so you know how to use the rules. Okay. Thank you for watching. I'll see you again.